Hello students, Assalamu alaikum, good morning. Today this is our second lesson and today's we discuss about reactivity series and extraction of metals. So first of all, what is reactivity series? Reactivity series is a list of metals arranged from the most reactive to the least reactive. It shows how easily a metal reacts with the substances such as water, acids and oxygen. Our key point is metals at the top are very reactive. Metals at the bottom are less reactive. Metals above carbon are extracted by electrolysis and metals below carbon are extracted by reduction with the carbon. Okay, students, so in simple words, what do you mean by reactivity series? Reactivity series is the list of metals arranged from the most reactive to the least reactive. It shows how easily a metal reacts with the substances such as water, acid and oxygen. And here is the four key points. Metals at the top are very reactive, metals at the bottom less reactive, metals above carbon are extracted by electrolysis and metals below carbon are extracted by reduction with the. Okay, so here is the list of metals and this list of metals are called reactivity series. When we go up, the reactivity is increase. Okay, so in the reactivity series we have two checkpoints. The first one is carbon and the second one is hydrogen. The carbon tells us if any metal that is above the carbon and you want to extract this metal, you use the method is electrolysis. And if any metal that is below the carbon and you want to extract this metal, you use the method is extracted by carbon reduction. The second checkpoint is hydrogen. If any metal that is above the hydrogen, that metal is reacted with the acid, and any metal that is below the hydrogen, that metal doesn't react with the acid. And in the reactivity series we have potassium, sodium, calcium, magnesium, aluminium, and then zinc, iron, tin, lead. Carbon and hydrogen is your non-metal. Why we place here? It is we place here for as a checkpoint. Like above the carbon, we use the method electrolysis. Below the carbon, we use the method is extracted by with the carbon reduction. If any metal is above the hydrogen, it is reacted with the it reacts with the acid. Any metals that below the hydrogen, it doesn't react with the acid. Okay, so here is different type of reactions of metals. When metal react with cold water, when metal react with hot water, when metal react with dilute acid, and when metal react with oxygen, what is your product? This is very important, student. When metal react with cold water, what is your product? Metal hydroxide plus hydrogen gas. And hydrogen gas is produced in the form of bubbles. When metal react with hot water, what is your product? Metal oxide plus hydrogen. Okay, student, look the difference. Don't be confused. When metal react with cold water, your product is metal hydroxide. But when metal react with hot water or steam, your product is metal oxide, not the metal hydroxide. Next, when metal react with dilute acid, your product is salt plus hydrogen, and this reaction is called a neutralization reaction. When salt is produced, this reaction is called a neutralization reaction. The last reaction is when metal react with oxygen. What is your product? Your product is a metal oxide. Okay, student. Next is order of reactions of metals. Order of reactions of metals. Reactions with the cold water. If any metal that react with cold water, this means this metal is very reactive, and this metal is present at the top of the reactivity series. Very reactive metals react quickly with cold water to produce metal hydroxide and hydrogen gas. For example, potassium, sodium, calcium. Okay, they can react with the cold water. For example, you have multiple choice question, which metal doesn't react with cold water? You have four options: potassium, sodium, calcium and zinc. So your correct option is zinc, because zinc doesn't react with the cold water. And the example reaction is, here is 2 sodium react with water and it is produce sodium hydroxide and hydrogen gas. Next student, reaction with hot water or steam. Moderately reactive metals react with hot water or steam to produce metal oxide and hydrogen gas. For example, magnesium, aluminium, zinc and iron. These metals react with the hot water, not with cold water. So that's why it is a moderately reactive metals. Example reaction is magnesium. When react with the steam, it produces magnesium oxide and hydrogen gas. Next student, reaction with the dilute acid. Metals above hydrogen in the reactivity series react with the dilute acid. We already discussed this thing. Any metal that is above the hydrogen react with acid, and any metal that is below the hydrogen doesn't react with the acid to form salt and hydrogen gas. And I told you, if salt produces any reaction, this reaction is called a neutralization reaction. The example is magnesium, zinc and iron. Example reaction is zinc. When react with hydrochloric acid, it produces zinc chloride and hydrogen gas. Next reaction with the oxygen. Most metal react with the oxygen to form metal oxide. Example is, when magnesium react with oxygen, it forms magnesium oxide. Okay student, here is the simple order from most reactive metals. Okay, if any metal that react with cold water, that metal is highly reactive. After that, if any metal that is react only with hot water or steam, that is less reactive as compared to the those metal that is react with the cold water. After that, acid, and after that oxygen. This means very reactive metals react with cold water, while less reactive metals may only react with acid or oxygen. Okay student, next topic is extraction of metals. Extraction of metals depends upon the reactivity series. If any metal that is above the carbon, we use the method is electrolysis, and any metals that is below the carbon, we use the method is reduction with the carbon. So metals are not usually found pure in nature except unreactive ones like gold and silver. Most metals are present in ores. What do you mean by ores? Ore is basically a compound mixed with the rock and impurities. To make metal useful for us, we need to separate them from their ores. Okay, so next is method of extraction. The method used to extract a metal from its ore depends on how reactive the metal is. Highly reactive metals need electrolysis. Less reactive metals can be extracted by reduction with the carbon. And very unreactive metals found as a native elements, or you can say found as a pure form. Okay, so here, if any metals that is above the carbon, we use the method is electrolysis, and that metal is potassium, sodium, calcium, magnesium and aluminium. After that, if any metal that is below the carbon, we use the method is reduction with the carbon, and these includes zinc, iron, tin, lead. For example, if I ask you, you want to extract iron from its ore, which method do you use to extract iron from its ore? You use the method is reduction with the carbon. Why? Because it is below the carbon. Okay, so next there is some basic key definitions. The first one is ore. What is ore? Ore is a rock that contains enough metal compound to make it worth extracting. Next is metal extraction, the process of getting pure metal from its ore. Next is reactivity series, a list of metals arranged in order of reactivity. most to least. Electrolysis, breaking down a substance using electricity. Molten, melted into a liquid form by heat. Next is blast furnace, a large furnace used to extract iron from its ore using coke, limestone and hot air. Slag, waste product. Another name of slag is calcium silicate formed during iron extraction. Flux, a flux is a substance like limestone added to remove impurities. Okay, student. These key definition we use when we discuss the method to extract iron from its ore and aluminium and for aluminium to extract from its ore. Okay, so here is the reactivity series and extraction method we already discussed. Above the carbon, we use the method is electrolysis. Okay, for example, aluminium from bauxite. Bauxite is the ore of aluminium. Between carbon and hydrogen, reduction with carbon. And this method we use for iron from hematite. And below hydrogen, that is least reactive, found as a native, no chemical extraction. For example, copper, silver. Okay, so here now we can discuss extraction of iron from its ore, and the name of the iron is hematite, and the formula is Fe2O3. Fe2O3. This is a diagram for this process. The method we use to extract iron from its ore is reduction in a blast furnace. Reduction with the, or you can say reduction with the carbon. What are the raw materials for this process is, the first raw material is hematite. Hematite is, what is hematite? Hematite is the ore of iron. And what is the formula for hematite? Fe2O3. Next is coke. What is coke? Coke is a uh, solid form of carbon, and that is fuel plus reducing agent. Next thing is limestone. The formula for limestone is CaCO3. What is the function of CaCO3? Removes impurities and act as a flux. Next is hot air, provide oxygen for combustion. Okay, so here this is a setup. Here this is blast furnace. Okay, this is a source of hot air, and here this is outlet for hot waste gases. Here student, here we can put here molten slag. Okay, and here is the ore of iron, that is hematite, and after that there is a, it can change into a pure form of molten iron here in the bottom. Okay, student, now we can discuss step by step how this process can be occurred. The first step is combustion of coke, or you can say the formation of a carbon dioxide. Coke burns in hot air to produce carbon dioxide and heat. What is the reaction for this step? Carbon react with oxygen and it forms carbon dioxide. The second step is formation of a carbon monoxide. Carbon dioxide react with more coke to form carbon monoxide, and the reaction is carbon dioxide react with carbon and it forms carbon monoxide. For carbon dioxide the formula is CO2, and for carbon monoxide the formula is CO. Okay, student, the third step is reduction of iron oxide. Okay, these three means the oxidation state of iron is, here is a plus 3. Carbon monoxide reduce iron oxide, or you can say the ore of iron, to iron, and this iron is the pure form of iron, and the reaction is Fe2O3 plus 3CO. It's changed into 2Fe plus 3CO2. Okay, so what do you mean by reduction? Reduction is the gain of electrons, and the second definition is loss of oxygen. So look here, student, this iron oxide here, it lost oxygen and it forms a pure iron. So that's why we call it uh, for uh, for extraction of iron from its ore, we use the method is reduction with carbon. So this is the main reaction where carbon reduce the iron and it forms a pure iron. Next step is to run thermal decomposition of limestone. What do you mean by limestone? Another name of limestone is calcium carbonate. And what is the reaction for this reaction? CaCO3 is decomposed into CaO plus CO2. Okay student, so the last step is formation of slag. How slag is formed? Calcium oxide react with silica impurity in ore to form slag. And what is the reaction? Calcium oxide react with silica and it forms calcium silicate. So students, these are the 5 reactions that occurs in the blast furnace for the formation of iron from its ore hematite. After that students, after these reactions, the product in the blast furnace is iron collected at the bottom, slag. The formula of slag is CaSiO3, calcium silicate floats on iron, and waste gases. And waste gases includes carbon dioxide, carbon monoxide, and nitrogen. So student, this is for today's lesson. Hopefully you can understand the topic. Stay blessed.